Good morning and welcome to Math TV with Professor V. It is Monday, July 10th, 2023. Here's your integral of the day. We have an indefinite integral of tan squared x plus tangent to the fourth x dx. If you want to give it a go, pause the video. Before I start solving this integral, I'm going to remind you of your Pythagorean identities because those are key here. And my brain starts thinking, ooh, maybe it's going to be time to use one anytime I see trig functions squared or raised to higher powers, okay? So the one that should be burned in the brain is sine squared theta plus cosine squared theta equals 1. And then we have two variations that you derive from this Pythagorean identity. The first one, which we're going to use in this problem, arises from dividing everything by cosine squared theta, okay? And I always tell my students, if you just memorize sine squared theta plus cosine squared theta equals 1 and you understand this process of how to derive the other two, then you're in business. So sine squared theta divided by cosine squared theta, that's tan squared theta, plus, this is just going to be 1, equals secant squared theta. Ooh, okay. So here's Pythagorean identity 1, Pythagorean identity 2. Where does the third one come from? Well, I'm going to go back to the original. And then this time, instead of dividing by cosine squared, I'm going to divide everybody by sine squared theta. Yes, yes, yes. Okay. And then notice, what do we get here? Sine squared divided by sine squared, that's 1. This is going to give me cotangent squared theta, and this here is cosecant squared theta. So honestly, I do encourage my students, just memorize this one, and then you can derive the other two as needed. I recommend memorizing only what's essential. Don't memorize a bunch of rules and things. You'll forget them. Long term, it's not going to stay there. Okay, so I'm looking here at this integral. Since we have tangent squared and tangent to the fourth, let me take out the greatest common factor, namely tan squared x. I'm hoping something cute will arise that I can simplify. So if I'm taking out tan squared x, I'm going to be left with 1 plus tan squared x dx. Scan the identities that we just derived. Focus on this one. Anything jumping out at you? Ooh, look, 1 plus tan squared x, that's equal to secant squared x, right? Because we're using x's in the integral. Fabulous. Are we excited by this as calculus students? We are, because we memorized our derivatives so beautifully. And so now I can see that it's time to make a u substitution. Let's see, who should u be? If u is tangent, not tangent squared, I said this in an earlier video. If u is tangent, tan x, then du would be secant squared x dx, which is perfect. I have that right here. If you tried it the other way around, okay, say you let u be secant x, this is no good, then du would be secant x tan x dx, okay? And I have a tan squared, which is one too many for this substitution to work out. So don't do this. No, no, no. Okay, we're ready to roll. Look at that. Integral. Tan squared x, now be careful, u is just tangent x, so since this is squared here, this term is going to be replaced with u squared. And then secant squared x dx, that's just du. Oh my goodness, look how this integral has just simplified, so relaxing. So add 1 to the exponent, divide by the new exponent. This is 1/3 u cubed plus c. And then go back, replace u with tangent. I'll just leave this 1/3 tan cubed x plus c. And that's it. Look how cute it cleaned up. My heavens. So that concludes the integral of the day. It wasn't too spicy, but did require you to go into the vault of trig identities and remembering your trig derivatives in order to solve it successfully. So if that's something that you found you need a little bit of review work on, no big deal. You can go back into my old video lectures on the pre-calculus or trigonometry playlists, and I have all of the review material there for identities and whatnot with trig. Okay, have a great rest of your day, everybody. I uploaded a new linear algebra video lecture. It's available to members only on vector spaces. Ooh, so you need to join the channel if you would like to watch that video. You can also join my Patreon if you want access to practice exams, worksheets, extra exclusive content. If you want to request content specific to what you're studying right now, that's the place to go do it. Just $9.99 a month. And also, if you're just curious on what I'm doing when I go to ballet, when I go to yoga, what math problems I'm working on, whatnot, you can follow me on Instagram and TikTok at MathTV with Professor V. Have a great one, you guys.